Now we'll come to this squeeze theorem. It says, suppose we have three sequences x, y and z, and such that for all natural numbers xn is always less than equal to yn, which is always less than or equal to zn, and if limit xn is equal to limit zn, then the sequence y will also be a convergent sequence and limit of y will be same as limit of x and z. Now let us take an example. Say for example it says, show that the sequence bn, which is 1 upon n plus 1 square plus 1 upon n plus 2 square up to 1 upon 2n square, it converges to 0. Now we know that n plus 1 square will be less than n plus 2 square and it will be less than n plus n square. Now if we take reciprocal, we can write 1 upon n plus 1 square will be greater than 1 upon n plus 2 square and it will be greater than 1 upon 2n square. Now what we'll also do is we'll also write this is greater than n square, so it will be less than 1 upon n square. Now using these two extreme values, we can say that this bn, now for all these n terms, the smallest value is 1 upon 2n square, so it will always be greater than n upon 2n whole square, and its maximum value is 1 upon n plus 1 square, which is less than 1 upon n square, so it will be less than n upon n square. So every term of the sequence bn will be greater than 1 upon 4n and will be less than 1 upon n. Now we take this limit n tends to infinite. Now this limit is 0, this limit is 0. Then using squeeze theorem we can say that the sequence bn, it is a convergent sequence and its limit of convergence is 0. And that is the answer to this question. Now here the question is, let an be a sequence of real numbers satisfying mod of an is less than equal to 1 for all n. It has defined capital An as 1 upon n, a1 plus a2 plus an. Then we need to find this limit n tends to infinite under root n into an plus 1 minus an is equal to what? Now we find an plus 1 minus an will be simply 1 upon n plus 1 a1 plus a2 plus an plus 1 minus 1 by n a1 plus a2 plus an. Now we can simplify this as n times an plus 1 and then minus a1 minus a2 minus an upon n into n plus 1. Now we'll multiply it with under root n. We can write under root n an plus 1 minus an will be under root n into n an plus 1 minus a1 minus a2 minus an upon n into n plus 1. Now this expression will always be less than or equal to under root of n and then n mod an plus 1 plus mod a1 plus mod a2 plus mod an upon n into n plus 1. Now mod an, it is less than or equal to 1. So this is less than n and this is 1 plus 1 plus 1 n. So we can write it will always be less than or equal to under root n into 2n upon n plus 1. Now here we will cancel this n with n. So this n an plus 1 minus an, it will be less than under root 2n upon n plus 1. Now we take this limit n tends to infinite this limit here is 0. Now since we have taken this mod sign here, so it should be this mod value. So this value, it can never be less than 0. The only value possible in this case is 0. So this limit n tends to infinite n an plus 1 minus an, it will be 0. And that's your option A. Another theorem is, if fn and gn be two convergent sequences, and if fn is less than or equal to gn, then limit fn will always be less than or equal to limit gn. And if fn and gn are two sequences such that mod fn is less than or equal to mod gn, then if limit gn is 0, then limit fn is also 0. Now let us take an example. Say for example, consider two real valued sequences xn and yn satisfying the condition that xn cube minus yn cube tends to 0 as n tends to infinite, then which of the following is correct? Now we'll write mod of xn cube minus yn cube, and it'll be equal to mod of xn minus yn into xn square plus yn square plus xn into yn. Now we'll multiply everything with 4. So we'll get 4 xn square, 4 yn square, and then 4 xn yn. Now we can rewrite this as mod of xn minus yn, and here it will be mod of xn minus yn whole square plus 3 times xn plus yn whole square. Now it will always be greater than or equal to xn minus yn whole cube. So we can write xn minus yn cube will be less than or equal to 4 xn cube minus yn cube. And the question it says the value of this limit is 0. That means the value of this limit will also be 0. So as n tends to infinite, xn minus yn must tend to 0. So the answer to this question is, as n tends to infinite, xn minus yn tends to 0, and that's your option A. Now in sequences, there are two more theorems, and the first one is monotone subsequence theorem, which says if x is a sequence of real numbers, then there exists a subsequence of x that is monotone. So every sequence of real number will always have a subsequence which is monotonic. And the next one is the Bolzano Weierstrass theorem, and it says a bounded sequence of real number has a convergent subsequence. So if the sequence is bounded, then it will always have a subsequence which is convergent. So these are two theorems for subsequences.